Welcome to Mathematics with Tom. I am Tom, and today we are going to take the inverse Laplace transform of y of s, and that will give us the solution to this differential equation that started this off, y double prime plus y equals cosine of omega t. So before we can apply this, the initial problem comes from this last term. We don't have an immediate Laplace transform that matches that pattern. So it's up to us to break it up in using partial fractions. So we're going to have to do some partial fractions work here. So here we go. So we start out with s over s squared plus 1 times s squared plus omega squared. And this is going to be some as plus b over, because remember s squared plus 1 is a second order, so we need a numerator of an order one less than that, over s squared plus 1 plus c times s plus d over s squared plus 1 omega squared. All right, multiply both sides by the lowest common denominator, and we pick up s is equal to, parentheses, a times s plus b times s squared plus omega squared plus cs plus d times s squared plus omega squared. Oh, whoops, plus 1. Plus 1. You have to be really careful on these. S squared plus 1. And then now there's a few different ways you can approach this problem. I've tried them both. I'm going to just multiply all that out and then start matching coefficients. So I get s is equal to as cubed plus as omega squared plus b times s squared plus b times omega squared plus c s cubed plus cs plus ds squared plus d. Okay, here we go. Let's do these in different colors to keep track. The first thing is, let's look at our s cubed components. This, if I look at that, my cubed components, I have an as cubed and a cs cubed, and there's 0 s cubes on the left-hand side, so I can say that 0 is equal to a plus c. Okay, and let's grab another color here. Let's look at our s squareds. S squareds, what do we have here? A b times s squared and a d times s squared. So I can, and notice on the left-hand side there's 0 s squared, so I can say that this is 0 is equal to b plus d. Okay, if we grab another color, like maybe this color here, we can say our s terms. Well, our s terms on the left-hand side, I have one of them, and that's going to be equal to, I have an as omega squared, so that's just going to be a omega squared. And do I have any more s terms? Oh, it looks like I have a c right there, a cs, so plus c, okay? And then finally, let's go to our constants. Maybe use this colored blue, I think it's different. Our constants is we have a 0 for my constant on the left-hand side equals, let's see, constants, my first constant comes from b omega squared, and then a d plus d. Okay, let's start working through these. So the first one, a plus c, this is the same as saying that a is equal to minus c. And we have another one like that. We have this red one here, and this would say here that b is equal to minus d. Okay, I think we're making some progress here. So this is going, now we can solve this yellow one using what we have just discovered. Use that one. So if I do this, A is minus c. So I could say that 1 is equal to minus c omega squared plus c. Factor the c. So I have 1 equals c times 1 minus omega squared. So c is equal to 1 divided by 1 minus omega squared. There's one of them. There's a c. So if we have c, then we also know what a is. So let's go back over to here. That gives me that a is equal to minus that. So I'm going to just write it this way. I'm going to write it as 1 over omega squared minus 1. And then what else do we have? Oh, from our d's, we can find out this. So now I can write in this color. I have b is minus d, so this is 0 equals minus d omega squared plus d. I can factor out the d's, so this is d times 1 minus omega squared. So this is the same as saying d is 0. Oh, d is 0. Okay, and now let's take a moment here and let's write these back. Oh, so if d is 0, I'm sorry. If d is 0, then b, which is minus 0, that's also 0. Okay, now let's go back and rewrite the original problem. Here we go. So the original problem, I'm going to just carry right off of this first line. This is now equal to y, I'm going to write it this way, y of 0, I'm going to write the constant out in front, y of 0 times s over s squared plus 1 plus y prime of 0 times 1 over s squared plus 1 plus, now this next one becomes the a term. This is going to be big and messy. The a term is going to be 1 over omega squared minus 1 times 1 over s squared plus 1 plus, and now the b was 0. The c is 1 over 1 minus omega squared times 1 over s squared plus omega squared. Okay, we're ready to do this. When I take the inverse Laplace transform, what I need to recall is this. We said that the Laplace transform of the cosine of omega t is s over s squared plus 1, or I'm sorry, s squared plus omega squared. In our problem, omega is 1. So this first term and this first term fits the cosine of omega t. So I pick up, my first term becomes y of 0 times the cosine of, and in this case, omega is just 1, so cosine of t, plus y prime of 0. Well, notice this one's a little different because it doesn't have an s in the numerator, it has a 1. Well, if I have the Laplace of the sine of omega t, remember that is the same as omega over s squared plus omega squared. Well, when omega is 1, then this term here matches the Laplace of sine. So this becomes the sine of 1t. Omega is 1. And then this next one is also, sine's going to match up with a sine of t. Oh no, gosh, I made a big mistake way back here. This should have been an s. And that also should have had an s on it. There we go. Oh my gosh, hopefully you didn't write that. Okay, plus, and then what do I have? Plus I have 1 over an omega squared minus 1, and then s over s squared plus 1. We already said that that is just the cosine of an omega, cosine of t. Okay, and if we go on, look at this. Our last one says plus 1 over 1 minus omega squared. So a little bit different than this other one. And now we're left with this. This one's a little different because now omega is omega instead of 1. So this is the cosine of omega t. And now notice that these two, notice that my first term and my third terms are like terms. So I'm going to write my final answer is y of t is equal to y of 0 plus 1 over omega squared minus 1 cosine of t plus y prime of 0 sine t plus 1 over 1 minus omega squared cosine of omega t. I hope that helps, and thanks for watching.